Hey guys, welcome to question MM192 of the Maths Methods Fortify study guide. Now, in this question, we've got a graph of a function with domain R, and part A, which is 3 marks, asks us to find or sketch the graph of the derivative function on the same set of axes. So I'm not going to do it on the same set of axes, just to kind of keep it clear, but you should obviously do that in the question when you're doing it. So first things first is to recognize that the derivative function is the gradient function, right? So we're going to have to sketch the gradient functions for each one of these separate functions, right? So this is a hybrid function. Doesn't say that in the question, but you should kind of recognize that. So this is I don't even know what you would call this, just a flat line. This is a linear, and this looks like it would be a quadratic. So there are first points that we need to kind of recognize. From here, we just go ahead and look at the gradients of each one of these. So let's start with this first section from negative infinity, because this looks like it goes from negative infinity to negative 2, right? So negative 2. What's the gradient of this line? Well, there's two ways of looking at this. The equation of this line is simply just y equals 4, right? It's just a straight line that goes across. Doesn't have a gradient. Well, it does have a gradient, sorry. It's flat. So if we take y equals 4 and we derive that, or we differentiate that, we get 0, right? Because it's just a constant. So our gradient of this flat line is actually just 0. So from negative infinity to negative 2, we've actually got a line on the 0, right? Because this y-axis represents our gradient of the original function, which means that if it's flat, it's going to have a gradient of 0, which means it's on the line. Cool. From here, we know that this line here from negative 2 to 0 is a quadratic, and it looks like it's going to be something like, x squared, right? And we can actually tell that negative 2, 4, negative 2, 4, this point up here, works with the equation f of x equals x squared, right? Because if we put negative 2 in for x, we get negative 2 squared, which is just 4. So we know that this graph is x squared. What's the derivative of x squared? 2x, right? So we know that our line goes through 0 because it has a c value there, and it's going to go down to negative 2, negative 4. So negative 2, negative 4, that's going to come up through here. Awesome. And these are actually not included. My bad. So these are not included, guys, because at these points here, this function is not continuous. It doesn't have the same gradient, like it's not smooth, if that's the way you want to think about it. So it has no derivative at these points. Even though that's a black circle, it's not continuous, which means that it doesn't have a gradient at that point, so we can't include it in the gradient function. So that's negative 2 there. Awesome. Now for this linear section here. So we know that this line is linear, and it has a gradient from negative 2 to 1, right? So its rise is 2, and its run is 1. So rise over run equals 2 over 1, because we're going up 2 and then 1 across, which means our gradient is equal to 2, which means that our gradient function is just going to be a line at y equals 2, right? Because our gradient is represented by our y value on this point. And guys, that's it. So this is what your answer should look like. Yeah, if you have any questions, let me know. But let's move on to part B. All you really need to do is just make sure that you kind of pay attention to what the gradient is of each one of these. Alrighty. So part B, and that was worth 3 marks, and each mark just comes for each section of the graph. So part B is 1 mark, and it asks us, what is the domain of the derivative function? So guys, as I explained, at negative 2 and 0, the the derivative function doesn't exist. It doesn't have a gradient there because it's not continuous at those points. Okay, so that means that our domain is x is an element of all real numbers except for -2 and 0, right? Because on this graph we had this bit here going down like this, like that, right? This does not have a gradient because it's like a sharp point if you want to think about it like that, so we can't include it at -2. This point here on x equals 0, that does not have a proper gradient, which means that we can't include 0 either, but everywhere else is fine, it has a gradient there. So that's your 1 mark. And guys, that's the end of question MM192. Please hit me up if you have any questions in the comments below. But otherwise, thanks for watching.